Let us start our discussion on node. Before going to the node, we should know the basic concept. I will repeat once again because this is very essential for understanding the node here. I will say what is the node, all those things. Suppose we have a smooth curve here. The given point is x1, y1 is the given point. Someone asked to find out the rate of change at that particular point. It means that per unit change in the input, how much change in the output at that particular point. If they ask it, what we can do, we take 2 points, left side and right side. Left side we can take x2 y2, right side we have x3 y3. And if you work out, because why we are going to take both the left side and right side, because you should have unique both. If you check it, what happens if you work out the y2 minus y1 divided by x2 minus x1, it will going to give the rate of change of per unit change in the input at that particular point whenever x I can say that x2 is very close to the x1. If left side, what happens if you x2 y2, if you take point it, left side coming to the first left side, if you take point left side x2 y2, whatever, if y2 minus y1 divided by x2 minus x1, whenever x is very close to the x1, you are going to find out the rate at which at that particular point it should be equal, whether from right side also. Try to understand. Right side, if you choose the point x3 y3, then whatever the y3 minus y1 divided by x3 minus x1 is equal to uh, x2 minus y2 minus y1 divided by x2 minus x1. Then only we can say that at this. But because if you what I want, once if you get two rates, left side and right side not equal, how can we say that we we should have unique per unit change in input? How can I say this is the rate or this is the rate? Two values there should be. Therefore, we can say that it is equal. But in the same case, what happens if suppose two branches of the curve, they are crossing each other? Okay, suppose this is the curve branch A, if you call this, and branch B. For this branch A, what happens? This is a function of y square is equal to x square into x plus 3. This is a function of the curve. At this point, if you leave for a while, you can, if you leave the branch B, what the left hand derivative and right hand derivative, they equal. Definitely they are equal because they smooth. As we make the angle, if you choose a point x2 y2, x3 y3, definitely, because it makes an why they are equal, because whenever if you choose a point x3 y3 and right side and x2 y2 left side, what I want to say is that the slope, the right side is at that particular point which gives by an line which joining the x3 y3 to the x1 y1, almost it is just like a line acting which makes an same angle with the x-axis. The left side also, if you join the line, I can say that x2 y2 with x1 y1, that is whatever the line joining the x1 y1 x2 y2, which makes an almost equal angle because they make angle with a positive direction of x-axis. Therefore, if you take a branch here, almost at the point they act as a straight line. Both points act as a straight line which the makes an angle. Therefore, you can say that for branch A, left hand derivative and right hand derivative are equal. Similarly, for branch B, the left hand derivative and right hand derivative equal. But keep in mind, I want to find out the rate at which we are going to means what is the change in the what is the change in the output per unit change in the input. But we have to, you should get unique slope. But the branch A gives something different for unit change in the input. This is the slope they are giving branch A, and branch B giving this is the rate at which. How can we choose that? That's region only the function is not, derivative is not unique. They are two values, so even the function is not differentiable at the node. Therefore, the node is called singular point. Very important thing. Okay, this is how we can say that the node is not differentiable. Node is called singular point. The keep in mind one thing very very easy here. Whatever if you draw tangent here at this point, branch A, definitely what happens in this case, whatever the line joining the x1 y1 to x2 y2, and they almost align with the tangent. Therefore I can say that the whatever the slope of the uh, I can say that. But keep in mind, if you not consider branch B, there is no, if you let us assume that there is no branch B, in that case what happens, definitely there is a unique slope, because if you don't consider branch B, there is a unique slope. Why? Because whatever the line joining the x1 y1 to x2 y2, and whatever the line joining the x1 y1 to the x3 y3, they almost align with the tangent drawn at that point. Therefore we can say that slope of the curve at that point is nothing but the slope of the tangent at that point, as we discussed earlier. But here there is, okay, if you there is no branch, you can say that it is definitely differentiable. But thing is, whenever there is one more branch B is there, at the same point it gives other, as change in the input, they gives two values. If you now, if you don't consider branch BA, then definitely it is also differentiable. But as we discussed, there are two slopes exist. For branch 1 there is a one more slope, branch B, for same change in the input per unit change, okay, at that particular point we have two slopes, therefore it is not differentiable. This shows some unusual behavior that is called node is called singular point. This is very important to understand.